Hello everyone and welcome to this, my General Mathematics Examination 1 multiple choice suggested solutions for 2024. Now, before I get started, a little bit of a rider. I am not associated with VCAR. I have not had prior knowledge to this, nor do I have the actual answers. But these are my suggested solutions. Now, fingers crossed I'm going to get them all right. But if there are any errata, and occasionally I make mistakes, which is really irritated, like you, I undoubtedly occasionally get tripped over. That'll be in the description below, or the errata below if you're watching this on YouTube. You can do me a massive favor and subscribe and hit a like on this video. It really does go a long way to sort of helping this channel grow. Who really wants to watch maths videos? No one. And if you can not unsubscribe at the end, that would be greatly appreciated. It also shows me that people out there actually have watched these videos. Right, let's see. I have not seen this paper. This is the first time I have seen it. I am sitting here bravely on my own. Hopefully you're going to get the right answers. Data analysis, question number 1. A group of students were asked to name their favorite color. Awesome. The results are displayed in a percentage segmented bar chart below. The percentage of students who named blue as their favorite color. Right, so the important thing here is blue. That seems to be this dotted section here. Right, so let's have a look. I'm going to zoom in and see what we can do here. So that seems to be going from 52 for 56 to, what's that value there, 74. Now again, I swear to you, I am going to use my calculator because my mental maths is fine, but in this situation, I would hate to make a silly mistake. So if I now go back and see if there is, in fact, 18%, which is what came out on my calculator, there is, and so I'm going to mark B there as my correct answer. Now, interestingly, this year they have changed the number of correct responses to only 4 in line with lots and lots of things. I don't know whether that's going to make the exam easier or harder. Hopefully you guys have found it lovely. Again, if there is anything you want to question or whatever else, by all means, put a comment below. But please be nice. Yeah, I'm honestly sitting here on my own, trying to help as many people as I can. Freddie organized a function at work. He surveyed the staff about their preferences. He asked them about their payment preferences, cash or electronic payment, and their budget preference, less than 50 or more than 50. The variables in this survey, payment process and budget, are, well, in this situation, the trick to this is actually, a lot of people think that this is numerical because it's got numbers in. It isn't. It is basically categorical. So that's categorical. They are definitely categorical. So in this situation, I'm going to say A as my correct answer for both categorical. So moving on to questions number 3 and 4, use the following information to answer questions 3 and 4. Okay, I will do that. The histogram below displays the population density in people per kilometer squared of the 27 countries in the European Union in 2021. The histogram has a log base 10 scale. Now, it fascinates me with VCAR because they have an endless way of writing questions. And previously, because the questions were all relatively similar, we would say where there's a 1, write 10, and where there's a 2, write 100, and when there's a 3, write 1,000. Because the log-based scales were generally 1, 2, 3. Now they're throwing decimals in. Right, so what's the actual question? The median value occurs in a column with a frequency of, well, median value. So first thing I want to do is find out how many countries there were. There were 27 countries. Add 1 divided by 2 gives me 28 divided by 2 is 14. So I'm looking for the 14th country. That is going to be my median. Now, there are 2 countries in there, there are 2 countries in there, there are 2 countries in there, there are 6 countries in there. And if we add those together, what do we get? 2, 4, 6, 7, 8, 9, 10, 11, and 12. So there are 12 countries up to here, which must mean that my 14th country actually lies in there. All right, so my 14th country, and again, it's wanting to know the frequency. The frequency of that is 9. So I'm going to say for that particular question that D was my correct answer. There is one outlier at the upper end of the histogram. This value could be, wow. All right, so this value could be, well, this is my outlier. And they're looking at it to be between 3.2 and 3.4. But you've got to remember that's a log base. So that means my value is 10 to the power of 3.2 and 10 to the power of 3.4. So if I fire up my calculator, and I'm going to use the ti-nSpire, guys, I know there's the class pad as well. The functionality for these type of questions is pretty similar. So if I do 10 to the power of 3.2 and 10 to the power of 3.4, hit enter, I'm looking for a value somewhere between 1,584 and 2,511. So turn that off. So where's my value? Between 1,580. Sorry about that. So I'm looking for a value. So I think the only answer there can actually be C. All right, so far we're on question 4. Nice so far. For those of you who are out there wondering, I actually will be using my revision resource, and you're probably going to turn around and say, what is it? It's a summary book. Yes, with VCAR questions, the harder ones, loads of stuff that I have basically put together over my time for teaching general maths. It's available from, guess where? Yeah, maffsguru.com, if that's going to be useful to you. If you can, like and subscribe to this video, that would be great as well, or subscribe to my channel. It really does mean a huge deal to me. Question number 5. The number of siblings in each member of a class of 24 students was recorded. The results are displayed in the table below. A box plot was constructed to display the spread of the data. Which one of the following statements about this box plot is correct? There are no outliers, right? Okay, well, I'm not going to know that without actually doing the data, so let's bring up my calculator. Let's go doc, insert a list and spreadsheet, and what I'm going to put in here is my title. It's always good to make sure you put your title in there. Nope, I don't want to do that. I get so used to hitting enter twice. There we go. So now I'm going to put my numbers in. 2, 1, 3, 2, 1, 1, 1, 4, 1, 1, 1. I'm just going to turn that off for a moment to see what data values behind there. It is 1, 1, 2, 1, 2, 2, 1, 3, 4, 2, 2, 3. And again, turn that off so I can see the data value is 1. Now, the first thing I tend to do is make sure that I've got the right information. I have 24 data items. It tells me I should have 24 data items. I'm just going to scroll up very quickly and check. There is nothing worse than making a silly mistake when you can just spend an extra minute checking 2, 1, 3, 2, 1, 1, 1, 4, 1, 1, 1. And again, how many ones have we got there? 1, 2, 1, 2, 2. 1, 3, 4, 2, 2, 3, and I know that last one was a 1. What am I going to do now? A doc, insert data and statistics. What's going to along the bottom here is going to go data. All right, and then because it says we are doing a box plot, I'm going to go menu, plot type, box plot, and ka-ching, there we go. So, which of these statements about the box plot is correct? There are no outliers. Well, there is very clearly an outlier because we can see this dot here. The value of the interquartile range is 1.5. Well, the value of the interquartile range is the upper quartile, which is that, Q3 minus Q1. Well, Q3 is 2, Q1 is 1. Nope, it is not B. The value of the median is 1.5. That's looking suggested, yes. All of the 5 number summary values are whole numbers. Well, that basically is not a whole number. So I'm going to go C there as my correct answer. All right, again, I like that question. That was cool. More than 11,000 athletes from more than 200 countries competed in the Tokyo Summer Olympic Games. Oh, I've been to Tokyo. An analysis of the number of athletes per country produced the following 5 number summary. The smallest number of athletes per country that would display as an outlier on a box plot of this data is, well, that's the smallest number that would display as an outlier. So the first thing we need to do is work out what our outlier is. And if we remember, our lower fence, which is going to help us to do that, is my lower quartile minus 1.5 times my interquartile range. Well, my lower quartile is basically 5 minus 1.5 times my IQR. Well, my IQR is given by 48 minus 5. So 48 minus 5 is going to give me 43. So 5 times 48 minus 5 is 43. Again, fire up my calculator. I'm not actually going to do that with it on screen. So hopefully you guys are happy with that. It's 5 minus 1.5. Oops. 0.5 multiplied by 43 gives me minus 59.5. All right, what about my upper fence? Is my upper quartile plus 1.5 times IQR, which is going to give me, what is that going to give me? Upper quartile is 48 plus 1.5 times 43. So we're going to end up with 48 plus 1.5. Oh, my calculator, my keyboard hates me. Times 43. 112. The smallest number of athletes per country that would display as an outlier on a box plot of this data. Well, in that situation, it's going to be have to be 113. All right. the smallest number of athletes per country that would display as an outlier. You see, it's interesting, isn't it? Because I looked there and said, oh, it's got to be the lower fence. But it's probably fairly obvious that in that situation, our first quartile is 5. And if I'm going to take away 1.5 of anything, it's probably not going to go. But again, it's good to be able to do what I did there a moment ago and say, well, if that was minus 59.5, there's no way I can have that. I had to regroup and go to my upper fence, which was 112.5. And then obviously the smallest number of athletes per country that display an outlier would be 113. All right, 613 definitely would also be an outlier, but 113 would be the smallest. Question 7. Fiona plays 9 holes of golf each week and records her score. Her mean score for all rounds is that. In one round, when she recorded a score of 48, her standardized score was Z of minus 1.75. The standard deviation for that score, well, okay, we know that the Z score is an actual score minus the mean divided by my standard deviation. All right, so the actual score, she recorded a score of 48. So my X value is 48 minus the Z score, sorry, was minus 1.75. The average, which is mean, is 55.7 divided by sigma. Now again, let's fire up my calculator. And what I'm going to do here is I'm going to do a solve, open brackets, negative 1.75 equals, so that 48 minus 55.7 divided by X, you can call it S if you want to, is equal to 4.4. So again, I'm going to say my suggested answer there was 4.4. Right, moving on to question 8. The scatter plot below displays the average number of female athletes per competing nation, females, against the number of Summer Olympic Games number from the first Olympic Games in 1896 to the 29th Olympic Games held in 2021. The least squares line has been fitted to our scatter plot. Fabulous. The equation of the least squares line is closest to. These questions come up literally every single year, and it fascinates me and sort of saddens me a little bit that there are still a large number of people who get these wrong. To find the equation of any straight line, all you need is 2 points on the line, and they do not have to be 2 dots on the line. And that, again, is a bit of a trick to the question. What you're looking to do is find where the line crosses through these axes lines as well, because that's way more accurate because you can read those off. So if I now highlight 2 points that the black line goes through and that I can read off pretty accurately, that's going to be one of them, and that's going to be another one. Now, I know I get people every year say to me, but this is my way of doing it. Hopefully you'll understand that. So 5, 6, 7, 8. So my coordinate is 8, comma, and that's 4. And we got 20, comma, 15. Now, I always write these on my paper just so that it's easy for me to do. Now, again, another trick to this is to look for the options they give you. Now, because the RV is always before the equal sign, that means what's on the y-axis is always in front of the equal sign. So no way can my equation start with number equal. So we're already pretty much there. They are too similar to try and work out. So now what I'm going to do is a regression analysis. And you're going to say, oh, that seems really, really silly. Nope. I'm going to go doc, insert, and a new problem. Now, if you don't know what that does, it basically separates out the variables from problem 1, 1.1, 1.2, 1.3 to 2.1, whatever else, so that I can use theoretically the same variables. I'm going to do up here num, and then FEMALE. I'm going to put my 2 coordinates in, so 8, 4, and then 20, 15. And I'm just going to do a regression analysis by doc, insert data and statistics. On the bottom, I've got num. Top, I've got female. Menu, analyze, regression, A plus BX. And obviously, in this situation, I've always fascinated why, bearing in mind we put on the y-axis female, why this really can't be programmed to put female equals num, but there we go. So what we're looking for, minus 3.333 plus 0.91, that would be closest to B. So in which case, now the reason it's not accurate is obviously those points aren't going totally through those, but they're as close as to be able to make it easy for me to have a look. So there we go. That was question number 8. Use the following information to answer questions 9 and 10. The least squares equation for the relation between the average number of male athletes per competing nation, males, and the number of Summer Olympic Games number is that. Okay, so the least squares equation for the relationship between the average number of male. Okay. Question number 9. Again, I sort of, when I say to my kids, whenever I see that table, I am quite literally going to grab my summary book. And yes, for those of you who are doing revision in 2025, 2026, whatever else, mathsguru.com, there is a full-on summary book that you can download. All right. It's got everything in there, including the hard VCAR questions that you can go through and sort of write the answers to. But the minute I see that, I'm like, that is the equation that has something to do with R equals SXS. But the thing of it is, I can't remember. I promise you, I can never ever remember that equation. So what I do is I put it in my summary book, and that's the whole point of a good summary book. My apologies for the noise of the page turning, but I'm looking now through my summary book, and you would argue, hold on a moment, shouldn't you know where it is? Yeah, I should. For the equation that says slope and intercept equals. So before I go any further, I'm going to write the slope is given by r times sy on sx, and I'm going to write that the intercept is y bar minus b times x bar. I haven't even read the question yet, bang, but I know it has something to do with that because I'm seeing it with mean and standard deviation. My males is my y, my number is my x, so I've pretty much got all the information. The value of the Pearson's correlation coefficient rounded to 3 decimal places. Come on, guys, please learn how to round to decimal places and, more importantly, significant figures. I want R, so the chances are I'm going to use that formula there, right? The value of Pearson's correlation coefficient rounded to 3 decimal places is. So B equals, oh, hold on, what's the value of B? Well, if you remember, we have Y equals A plus BX. So I'm looking for the number in front of my EV, and again, it's minus 1.27. So I now know that my B value is minus 1.27 is equal to R that I'm trying to find. SY, so the standard deviation of Y, which is 19, divided by the standard deviation of X, which is 8.51. Fire up my calculator. In this circumstance, I can happily go back to problem 1.1, but let's do a solve. Minus 1.27 equals brackets R times, don't forget the times, 19 divided by 8.51. And then we're going to do comma R, hit enter, gives me minus 0.569. So there we go, minus 0.569. I'm going to go with A as the correct answer. Question number 10. At which Summer Olympic Games will the predicted average number of males be closest to 25.6? All right, at which Summer Olympic Games will the predicted average number? Well, that's my prediction. Males equals 67.5, so I'm going to write that here. Males equals 67.5 minus 1.27 times number. Which Summer Olympic Games will the predicted average number of males? So we're going to try and find my average predicted number of males to be closest to 25.6. All right, so sorry, try that one again. I've highlighted the wrong thing. Will the predicted average number of males be closer to 25.6? Yep, so in which Summer Olympic Games? So we want to find that number. Yep, I highlighted that correctly. So we now know number of males is going to be 25.6. Equals 67.5 minus 1.27 times num. Again, what am I going to do? Fire up my calculator and let's do solve. 25.6 equals 67.5, yep, minus 1.27 times n, and I'm going to solve for n. Hit enter. He says, what happened there? My brackets were in the wrong place. Comma n. Hit enter, and I get 32.99, so 33. I think 33 is going to be my correct answer. So there we go, 33 is my correct answer. Remember to turn off your calculator. And we got more questions. All right. The following use the following information to answer questions 11 and 12. The number of breeding pairs of a small parrot species has been declining over recent years. Awesome. Have you subscribed to my YouTube channel? If you can, it would be massive, right? It just lets me know that you have followed and watched along and that it's been useful. And if you can like this video and spread it out there, I'd be grateful as well. No one watches maths videos. You're only watching this because you need to. But anyway, the table below shows the number of breeding pairs counted pairs and the number year for the last 12 years. A scatter plot of the data is also provided. The association between pairs and years is nonlinear. That's good. It looks nonlinear. The scatter plot can be linearized using a log base 10 transform applied to the EV. So we are now going to log base 10 year. Notice I write that on as a visual reference. The least squares equation calculated when the transform data is closest to. Right, so bearing they said it's the EV, all right, it's not going to be, it's got to be pairs equal. So I can automatically discount those two values there. Okay, and again, the other two are very, very close. So I'm going to have to actually do this information. Okay, so firing up my ti-nSpire, what I'm going to do is going to go insert problem, because I might as well have a new problem. Here we go. Right, what I'm going to put there, I'm going to put my data in year and PAIRS. Thank you very much. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now again, what did you notice there? I was so quick, I could have made a horrible mistake. And you're always advised just to slow down a little bit. 320, 250, what have we got? 225, 208. And I keep checking 190, 180, 170, 165, 160. 158, 155, and 150. Hit enter. There we go. There are my 12 values. Now, it's telling me I've got to do a log base 10. All right. So I'm just going to rewrite that on the bottom here. Log base 10 of year. I'm going to scroll up. Now, automatically, two of these cannot be right. All right. Because, again, they've told me to do a log base 10 of my EV. Well, this would be log base 10 of my RV. So that can't be right. And that can't be right. So that's automatically wrong because they've told us that pairs is my RV and we're trying to do a a log transform for my EV. All right, so log 10 years. So the first thing is my equation got to be pairs are equal. I can't narrow that down. So I've got to do this. Here we go. So the first thing I'm going to do up here is I'm going to type log year and hit enter. And I'm going to do equals and I'm going to do control and log base 10 and a tab. And I always hit the var button to make sure it gives me the variables. And I want to do year. So I'm going to hit enter and there we go. Now, if your calculator comes out in fractions, it just means you're in the wrong mode. Doc, settings and status, document settings. Make sure this display digit here says float and make sure calculator mode is approximate, all right, for general maths. Right, what am I going to do now? What am I going to do my regression analysis? I'm going to doc, insert, data and statistics. On the bottom, if you remember, is log years. On the side now we know is pairs. Yep, that seems to be a lot straighter than that original graph. Pretty animation. And what have I got to do now? I'm going to go menu, analyze, regression, a plus bx. Move this because I want to be able to see this plus and minus that sometimes can get covered by dots and tricks people a little bit. So what do we get? 303. So let's scroll up a little bit. 303 minus 151. I'm going to go with D as my correct answer. Okay, so question number 12. A reciprocal transformation, let's turn this off for a moment, applied to the variable pairs can also be used to linearize the scatter plot. When a least squares line is fitted to the plot of 1 on pairs versus year, the largest difference between the actual value and the predicted value occurs at year. Wow, this is an interesting question. So first thing first, let's go back here. Fire this up. I'm now going to do a reciprocal on pairs. So I'm going to write rec pair, which is what I tend to write, equals 1 divided by, hit my var button, and pairs, hit enter, and there we go. So that's my values. I'm now going to go back here and say, so this now becomes rec pair. This has to go back to year because we only ever transform one thing. There we go. So that is my rec pair and my year. So what does it say? When the least squared line is fitted to the plot of 1 on pairs versus year, yep, the largest distance between the actual value and the predicted value occurs at year. Well, this is going to be an interesting one because what I can actually do is I can go menu, analyze, residual, and I'm going to show my residual plot. And we are going to see here that actually the largest difference, all right, in actual value and predicted value occurs out. Well, this here has a residual of minus 0. That seems pretty far away from that dotted line. That there has a residual of 0.00332. I'm fairly sure that this is actually going to be 1. All right, so I'm going to suggest 1 for a moment. Just look one more time. So the largest distance is going to be that 0. That seems far away. That's point number 2. That's close to my line. Point number 11. Where's point number 11? 9, 10, 11, and 12. Now, so if I look at those 4 points, that point there, number 1, is the furthest away. 2 is actually right nearly on the line. 11 and 12 certainly isn't lower than that point there, so I'm going to go with 1. Oh, that was an interesting question. I like that one. Right, moving on to the next one, questions 13 and 14. The school runs an orientation program for new staff each January. The time series plot below shows the number of new staff new for each year from 2011 to 2022 inclusive. Okie dokie. Right, what have we got here? All right, that's fine. A time series is smooth using 7 median smoothing. The smooth value for new of new for the year 2020-16 is. So when we do 7 median smoothing, 2020-16 is my middle pot. If I've got 7, I'll just check it says 7. Yep, I've got 7 median smoothing. So I want 7 points in total, which means there'll be 3 points on that side and 1, 2, 3 points on that side. Now it's really hard for me to show now, but when you are median smoothed, you are effectively now taking a straight line and moving it up until you get to which point? Well, you've got already your 4th point across to the left or the right is the middle point horizontally. So we'd be looking for the 4th point vertically. All right. So if I took a ruler and went up, that would be my first point up. That would be my second. That would be my third. I think that would be my 4th. So if I read that off, I'm hoping I've got a solution as 10 as my smooth value of new. All right. Again, 7 points. I'm looking for the middle of those 7, which is the 4th data item vertically. 1. Oop. He says not wanting to do that. I wanted to highlight 1, 2, 3, 4. I really wish I could get a ruler for this particular app. The number of new staff in 2023 is added to the total number of new staff from the previous 12 years. For these 13 years, the mean number of new staff is 11. So the number of new staff in total is right. So whenever you're working out the mean, right, you want the total divided by the number. So the number of new staff in 2023 is added to the total number of new staff from the previous 12 years. Okay, so basically I've got to find my total of those 12 years plus this new number of 2023 for these 13 years. That means that that's going to be 13. We've got the mean number is going to be 11. So I've got to add all those data items together for new staff. Well, how am I going to do that? Oh, you've guessed it. Fire up my CAS calculator. Let's go back to something nice and easy I can use. Right, the problem is my calculator is now obscuring things. So let's see what I can do this. We got 14 plus 11 plus 9 plus 6 plus 11 plus 13 plus that dot there, which is 12, plus my eyes are going funny, 6 plus 10 plus 14, 15 plus 12 plus 10. All right, so let's just check that again. So we've got 14, 11. So we got, I'm just going to write these down on the side. 14, 11, 7, 6, 11, 13, 12, 6, 10, 13, 12, and 10. Let's just check that one. I've got 14, 11. Oh, that's interesting. I've written a 9 there. So is that 9 or a 7? It's a 7. See, now, isn't that lucky that I did that? You're all screaming at me at the moment going, it's a 7. Don't put 9. It's a 7. So 14, 11, 7, 6, 11, 13, 12, 6, 10. Again, I've done it again. 15. Is it 15 or is it 13? 40 is 15. No, hold on. It's 15. So that's actually a 15. Ooh. 15, 12, and 10. There we go. Oop, not that. Right. So if I hit enter, I get 127. I'm beginning to panic now that I haven't got this right. So that number there is 127. I'm going to open my CAS, or I've already got it open. I'm going to do a solve, if you will, please, of 11 equals. Sorry, my fingers just hit that. 127 plus x, because that's the number of new staff, divided by 13. Do comma x, hit enter, and we get 16, which is a suggestion. So I'm going to put 16 and later on come back and check that I've actually done that one correctly. Question 15. The table below shows the total number of cans of soft drink each month sold at Suburban Cafe in 2023. The 6 mean smooth value of the number of cans sold with centering on month 5 is. These questions are great, but they take some time. So what I tend to do now is if I've got the 6th month, right? So that's the one we want our centering on. Oh, no, it's not month 6, you muppet. It's month 5. Try that one again. First thing I want to do is I want to do the 6 values on the left of the number 5. And that means that I therefore am going to be wanting to do those 3 and those 3 added together. Right, so firing up my CAS, what have I got? I have got 321 plus 365 plus 306 plus 254 plus 308 plus 354. I'm going to divide that by 6, gives me 318. I'm going to write up there, he says, hopefully not in highlighter, 318. I'm now going to repeat the same on this side, which means I need, where am I? Those 3 values and those 3 values this time. Now again, that's nice and easy here because what I do is copy that down. I do plus 357. I go back and delete the 321. Hit enter, divide by 6, hit enter, is 324. He says writing once again in highlighter. And how do I do that now? Well, I add them together, 318 plus 324, and I divide by 2. So 318, if you will, plus 324. Oh my goodness. Try that one again. 318 plus 324 equals, divide by 2, gives me 321. So I'm going to go with C as my correct answer. Turn off my calculator. The table below shows the seasonal indices for the monthly takings of a bistro. The seasonal indices for month 3 and 6 are missing. Okay. The seasonal index for month 3 is twice the seasonal index of month 6. All right, so if I call this X, that is going to be 2X. The seasonal index for month 3 is closest to. Now, the first thing is we know that all of these seasonal indices must add to the number of months or data items that we have, or raw data items. So all of those adds to make 12. So again, firing up my calculator, I'm now going to add all of those seasonal indices together that I know. I've got 1.08 plus 1.13 plus, not the 2x, 0.92 plus 0.67 plus 1.09 plus 1.35, 0.82, 0.88, 1.01, 0.98. Now, when I add those all together, I get 9.93. So I now know, he says, writing in highlighter again, if I got $1 for every time that happened, 9.93. If you can subscribe to my YouTube channel and hit the like button on this video, it really does go a long way to supporting me and this channel. That like really is great, but the subscriber lets me know that you actually watched the video. I mean, to be honest with you, who watches maths videos? You're only watching this because you want to know the answers. Not exactly for my sparkling personality, is it? 9.93. I got to add on those 3 x's. Why is it 3 x's? Because 2 x's here and 1 x here. And we know that all of that must give me 12. All of those must give me 12. So using my calculator now, I can do 12 minus 9.93. And if you want to, you could solve. I'm going to divide that by 3. So it's going to give me the value of x is 0.69. So I now know that's 0.69. I know that that value is going to be 2 times 0.69, which is 1.38. The seasonal index for month 3 is closest to 1.38 is C. And I can see where people are going to get tricked there. I can see that they're going to basically get the value of 0.69. Hopefully that hasn't tricked you. It's a good question. Well, if I'm honest with you now, that data and statistics was actually quite nice. A little bit time consuming maybe, but on the whole, nothing there that I think was particularly horrible, which worries me about what's coming up next. Now, obviously, if you are preparing for this in 2025 and are looking for a really good revision resource, guess what? You can get one from mathsguru.com. Yay! Yeah, I know. It's downloadable from there. It's got all of the stuff that I provide, plus all the hard VCAR questions, and there's extra books and all sorts of stuff as well. Right, recursion and financial modeling. A first-order linear recurrence relation of the form that generates the terms of a sequence. A geometric sequence will be generated if a geometric sequence Basically, this is bound to foundational knowledge is only possible if this value of D here is 0, all right? And R is greater than 1. So D has to be 0 to be able to have some sort of geometric sequence. So as far as I'm concerned here, the only answer that is possible is D. That's a bit of a tricky one for a first question. All right, so R equals 2 and D equals 0. R has to be greater than 1 and D basically has to be equal to 0. Okay, I wonder how many that's tricked. Trevor took out a reducing balance loan of $400,000 with interest calculated weekly. The balance of the loan in dollars n weeks after n weeks, Tn can be modeled by that recurrence relationship. Assuming there are exactly 52 weeks in a year, the interest rate per annum for this loan is... Okay, so I've now got R, which is 1.00075 minus 1 times 100 to put it into percentage times my compounding period, which is 52. So again, that formula is in that formula books. It's R minus 1 times 100 times the number of compounding periods. Firing up my calculator because there's no way I'm doing that in my head. 1.00075 minus 1. Hit enter. He says minus 1 and doesn't actually minus 1. Times that, fudge fingers, by 100. Gives me that, and I'm going to times that by 52. Gives me 3.9%. So I'm going to go for B as my correct answer. I'm going to move that out of the way, move my keyboard over because I'm getting a little frustrated with that at the moment. All right, so assuming exactly 52 weeks in a year. Yeah, I'm going to take that minus 1. 1.00075 minus 1. Question number 19. Liv bought a new car for $35,000. The value is not going to be a Tesla, is it? Lol. The value of the car will be depreciated by 18% per annum using the reducing balance method. A recurrence relation that models the year-to-year value of her car is of the form The value of K is basically going to be 100 minus 18 divided by 100, which is going to be, I'm doing it on a calculator, at 100 minus 18 divided by 100, 0.82. C is going to be my correct answer, all right? Because if it reduces by 18% per annum, it's basically 82% of what it started with each year, and so that's going to be a 0.82. Danica, or Danica? Invested $2,000 for 3 years at 4.4% per annum, compounding quarterly. To earn the same amount of interest in 3 years in a simple interest account, the annual simple interest would need to be closest to. Simple interest, all right, is basically given by I is equal to P RT over 100. Right, so simple interest is basically P RT over 100. I'm sure there are other ways of remembering it. I just remember this from the years and years of doing this in a sort of junior maths. Okay, so the first thing we need to try and work out to earn the same amount of interest is how much interest she actually earned. So I'm going to fire up my financial solver and let's see whether that's actually going to help me. He says menu 8 and 1. So what have we got? N. Danica did a compounding quarterly, did the same amount of interest in 3 years in a simple interest. So she's got 3 times 4 because she's got 3 years compounding quarterly. So there's that. There's 4.4%. She's invested 2,000 minus 2,000. She's not making any payments. We're looking at the future value to work out what interest she actually ends up with. Payments per year is 4. So what I'm going to do now is if I hit enter, her $2,000 has grown, he says, and I'm going to switch off my screen for a moment, to become 2280.57. So she's gained $280.57 in interest. So I'm now going to make that 280.57 is equal to principal, which is 2,000, times the rate, which we're trying to find. I think that, yep, so let's call that R, times T, which is 3, divided by 100. So I'm going to fire up my calculator again. Let's crash out of financial solver. Let's see what happens now when I do solve of 280.57 equals 2123 times R times 3 divided by 100. And we're going to do comma R and hit enter. 4.676, so 4.68 is going to give me B as my correct answer. Lee took out a loan of $121,000 with interest compounding monthly. He makes monthly repayments of that for 5 years until the loan is repaid in fully. The total interest paid by Lee is close to, again, these are the type of things that you put in your summary book, and they are great. So if you can do me a favor and subscribe, that would be awesome. It just shows me that you've watched, and if you can click a like on this video, then YouTube go, yay, hold on a moment, more than 8 people are watching one of his videos. Cool, maybe he's doing something useful. And again, no one watches maths videos. I get that. You only watch it if you need to. So, yeah. Moving on from the lonely stuff. Right, a lot of people don't realize that what we need to try and do is we work out, firstly, how much did he pay in? How much did the loan or investment change by? And then the difference is the interest. So the first thing is he makes monthly repayments of. So I'm going to do 2228.40 times by 5 times by 12. All right? Because he's making monthly repayment. That is how much he has basically paid the bank for the privilege of that. So fire up my calculator, 2228.40. I'm going to multiply that 5 and multiply that by 12. So he has paid the bank a grand total of 133, he says, writing in flipping rubber again. That's how much he's paid the bank in repayments, yeah? How much did he borrow? Well, let's change that to pay or borrow. He borrowed $121,000. Let's turn that off for a moment. So the rest must be interest. The difference between that must be interest. So if I put that into my calculator, and if you'll excuse me by not bringing up the screen again, 133,704 minus 121,000, hit enter, gives me 12704, which is going to give me D as my correct answer. So again, these type of questions are fairly formulaic. Just work out the monthly repayments and how many of those have been made and how much he's paid the bank or paid into the bank. Look at what was started with, and the difference would be my interest. Use the following information to answer questions 22 and 23. Stuart takes out a reducing balance loan of $240,000 or with interest calculated monthly. Stuart makes regular monthly repayments. 3 lines of the amortization table are shown below. The principal reduction associated with payment number 2 is closest to. So we got to work out my principal reduction. To do that, and again, these are fairly formulaic questions, I've got to work out my line interest rate. How do I do that? Well, to work out a line interest rate, you take the interest divided by its previous balance and times by 100. Again, I'm not going to bring my calculator up for that. I'm just going to do 960 divided by 240, 123, hit enter. And so my line interest is he says, 0.004. Now, I could times that by 100, which would give me 0.4%, but actually all I need to know is that if I take any value in here and multiply it by 0.004, I'm going to get that interest, right? So I will bring up my calculator now. If I do 240, 123, times it by 0.004, I'm going to get that $960. So now to work out the interest that's going to go here, all I need to do is multiply that value there by 0.004. And again, because it will obscure my screen, I'm going to do 218.95, and I'm going to multiply that by 0.04. 0.004. That would have been awkward. And that gives me $952.88. Rounding to 2 decimal places. Now, again, a lot of people get confused. So, well, how do I get the principal reduction? How do I know where this figure came from? Well, ultimately, it's either going to be those 2 added together if it's an investment, or those 2 subtracted if it's a loan. If you don't know, just sort of in this situation, it's pretty clear that that minus that must be that. So, in the same way, I've got this minus that will give me my principal reduction. So, what have I got? My calculator is still on there, 2741.05. I'm going to subtract from that to 952.88, and I get 1788.17. Is that one of my answers? 1788.17. So I'm going to go with C as the answer to that one. The number of years that it will take Stuart to repay the loan in full is closest to. Now, again, I'm sure there's lots of other ways of doing this. I do this with Financial Solver. I think it makes life a lot easier. So we're going to try and find N. So I'm going to leave that one for the moment. My interest rate per annum, okay, is going to be 0.004. I'm going to multiply that by 100 to turn it into a percentage. And I'm going to times that by 12. Now, the reason I'm timesing it by 12 is because that's a monthly interest rate and I want a yearly interest rate. So I'm going to times that by 12. So there we go. That gives me my interest rate at 4.8%. My principal value was 240, and because I've paid it in, it's minus 240000. My payment, I'm getting money of 2741.05. My future value we want is 0. That's 12, 12, 12. So if I hit enter now, I get that. So I get 100 and effectively 8. All right, so it's no way 108 years because if you remember, we are compounding monthly. So if I divide that value by 12, he says, and again, I'm so sorry I didn't bring up my CAS for that. Just use the financial solver to put the information in. Frustrates me. All right, I've been really good up until now, so let that one slide if you can. So that's come up with 108. So what I'm now going to do is hit escape out of financial solver. 108 divided by 12 gives me 9. So in which case I'm going to go for 9 years as my correct answer. Now, moving on to question 24, it's awesome. It's a change of conditions question. Andre invests 18,000 in an account for 5 years with interest compounding monthly. Moving on to question 24, Andre invests 18,000 in an account for 5 years with interest compounding monthly. He adds an extra payment into the account each month immediately after the interest is calculated. For the first 2 years, the balance can be modeled by that recurrence relationship. Okay, after 2 years, so there's my changing conditions. I tend to put a line in there so that I'm like, hello, there's a change here. Andre decides he would like the account to reach a balance of 30,000 at the end of the 5 years. He must increase the value of the monthly extra payment to achieve this. The minimum value of the new payment for the last 3 years is closest to. Right, so the first thing we need to do is the first 2 years and then the last 3 years. Now, you'll notice I've already got my NIPV PMT. That's because I thought about this question earlier. Right, now, there's lots to this that we need to know. So for the first thing, we got 2 years. So for the first 2 years, that's going to be 2 times how much is it compounding, or what's my compounding? It's compounding monthly. So that's going to be 12. So that's going to be 2 times 12. What on earth is my yearly interest rate? Well, my yearly interest rate is derived from that there. And if you remember, you get that by doing 1.002 minus 1 times 100 to turn it into a percentage times the compounding periods when this situation gives me 12. Now, when I do that, I actually, and you can do this on your calculator if you want, I get an annual interest rate of 2.4%. My principal value, he invested 18,000, so it's minus 18,000. His payment, again, the trick to the question here was not plus 100. He's putting money in, so it's a minus 100 here in the financial solver. We want to find our future value, and our CPY PPY is 12. Now, the reason we want to find our final value is because that becomes the start value at the end of the 3 years. Because we know at the end of the 5 years, he wants to have $30,000 in there. The interest rate is going to stay the same at 2.4. N now is going to be 3 times 12 because he's already done 2 years of the 5. He's got to do another 3. PMT is what we're going to find, and CPY PPY is 12. By writing that there, it just keeps me focused. So bring up my calculator. We'll go menu, finance solver. Right, so we've got 2 times 12 there. Interest rate of 2.4%. Principal value is minus 18,000. He's making initial payment of $100. We don't know the final value. PPY is 12, CPY is 12. So let's find out what his final value is. It was $21,340.18. Now again, while I'm writing 18 cents there, I'm actually going to copy that down and I'm going to paste it in there by using copy and paste and remembering to change the sign with all of those decimal places. We now at 3 times 12, so that's got to change to 3.12, 2.4. That's my new present value. My payment I'm trying to find, my future value is going to be 3123, and hopefully when I hit enter here, I'm going to get, he says, dropping a load of paper on the floor, $189.55. So my correct answer for that, I'm going to say, is A. Okay, let's move on to question. Oh, well, that's it. We're done for finance. And again, I think that was quite nice. Again, my apologies out there if that's not the case and you found some of that hard. Obviously, I've done this for years and I'm just trying to make it feel like, okay, that was manageable. Now, if you've just tuned into Matrices, thank you very much. If you're going to like my video, that will tell you, VCard, that actually it's worth watching. If you can subscribe, it would be amazing because it shows me you've watched and really does go a long, long way. And please turn off notifications if you never want to hear from me again. but it does me the world of good. And if you are in 2026, 2027, 2028 doing this, there is the Maths Guru Revision Resource, which is basically a summary book with VCAR questions and all the hard stuff. In fact, you get 2 books if you head over to Maths Guru and sort of take out a subscription, as it were. It's very cheap. Let's go to matrices. Matrix J is a 2 by 3, okay? K is a 3 by 1. L is added to the product of JK. The order of matrix L is, all right, so if you are going to take the product of J and K, then we're going to end up with, because the middle 2 are the same, that's good. The outer 2 are the order, 2 times 1. To be able to add, it's got to have the same order, so it's going to have to be B, a 2 by 1, right? You can only add matrices of the same order. A market stall sells 3 types of candles. The cost of each type of candle is shown in matrix C's below. Towards the end of the day, the cost of each item is discounted by 15%. Which one of the following expressions could be used to determine each discounted price? Is it 0.15C, 0.85C, 8.5C, or 15C? When you discount by 15%, you started at 100%. You take away the 15%, which gives you 85%, and then you turn that into a decimal, which will give you a 0.85 by divided by 100. And therefore, it would mean that we would multiply all those values by 0.85. So I'm going to say B is my correct answer. Question 27. Consider the following matrix where H is not equal to 0. Okay, the inverse of this matrix does not exist when G is equal to... Okay, for an inverse not to exist, we would have to have the opposite corners when multiplying equal 0. Okay, so in that situation, we would have to have 4H minus 8G is equal to 0. Okay, so if I now move that to 4H equals 8G, H would have to equal to 2G, all right? So if H is equal to 2G, then basically that would be the case, but it says G is equal to, so G would have to be equal to H divided by 2, which would give me B as my correct answer, okay? Very, very interesting there. I suppose there's other ways of doing it. You could have substituted G in and tried to work that out, but the inverse of this matrix does not exist, and the only way it does not exist is if the determinant, and that is effectively this number times that number, minus that number times that number, is equal to 0. A primary school is hosting a sports day. Students represent one of the 4 teams, blue, green, red, or yellow. Students compete in one of the 3 sports, football, netball, or tennis. Matrix W shows the number of students competing in each sport and the team they represent. Matrix W is multiplied by the matrix to produce matrix X. Element X31 indicates that... Oh dear. Okay, W is multiplied by that matrix. So W, we get that, is going to multiply by 1, 1, 1, 1, 1. So basically that's going to sum all of my rows together. So basically we're going to end up with the sum of all the F, N's, and T's. Matrix element 3, 1. So what are we going to get? We're going to get, that was a 1, 2, 3 by 4. And that's a, he gets rid of one of those ones, 4 by 1. So we can get a 3 by 1. Okay, so element X31 indicates that. That's row 3, column 1. So that's what that one there. It's got something to do with T. Basically, 280 students compete in the tennis team. I reckon C is my correct answer. Because basically that's the only one it can be, right? Because if I add those together, that is a column matrix, so it's going to sum all of my rows. So the first sum is going to be the total number of people who do football. The next one's going to be the total number of people who do netball. That one there is going to be the total number of people who do tennis. And so I'm assuming if I do 63 plus 76, I'm going to do it just for completeness because I would hate to mess this up thinking it's too easy. If I do 63 plus 76 plus 66 plus 75, I get 280. C is the correct answer, okay? That's just understanding what matrices is all about. A tennis team consists of 5 players: Quinn, Rosie, Siobhan, Trin, and Ursula. I love Ursula. Under the sea. No, sorry, that's The Little Mermaid. Yes. When the team competes, players compete in the order of first, then second, then third, then fourth. Okay, a fifth player has a bye, does not complete. Never heard of that before I came to Australia. On week one of the competition, the players competed in the following order. This information can be represented by matrix G, shown below. Let G of n be the order of play in week n. The playing order changes each week and can be determined by the rule that to get to the next week, you do G from the previous week times by my permutation matrix. Which player has a bye in week 4? Which player has a bye in week 4? Well, believe it or not, we can do that on my calculator. Let's see what actually happens here. So the first thing I'm going to do is I'm going to define a matrix. I'm going to put my permutation matrix in, which is a 5 by 5. Hit enter. 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 1, and 2, 4, 0, 4, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0. And I'm going to store that by doing control and store, and I'm going to call it P. Fabulous. Then I'm going to do a, what am I going to do here? A 1 by 5. 1 by 5? Yep. Which is going to give me Q, R, S, T, and U. And I'm going to store that. Not caps. Let's actually store that in G. Fabulous. Now, to do this repetitively, basically, I could do it one at a time, but I know that I want to do it in week 4. So this information, I'm just going to check what that says below. On week 1 of the competition, so 1, 2, 3, 4, I'm only going to do it 3 times. Okay, so I'm now going to go G times P to the power of 3. And the reason it's power of 3 is that basically that's going to do that 4 times, because that's going to be week 4. And again, the information here, hopefully I'm not tricking myself here by overthinking it. That's week 1, right? So this here is week 1. And I want the 4th week in week 4. So that's week 1, 2, 3, 4. So I need to do P 3 times, which gives me U, T, R, Q, and S. And that last one is the bye. So I'm assuming that therefore Siobhan is going to be the one with the bye. Which player has a bye week 4? I'm going to go with Siobhan. And I'm going to stop thinking about it because otherwise I'm going to go mad. Data has been collected on the female population of a species of mammal located on a Rhode Island, Leslie matrices. The female population has been divided into 3 age groups, with the initial population at the time of data collection, the birth rate and the survival rate of each age group shown in the table below. The Leslie matrix that may be used to model this particular population is where, if you remember, for a Leslie matrix, the birth rates go along the top, the survival rates go down on the diagonals. So the birth rate, I'm going to have 0 there, 1.8 and 1.2, and I'm going to have 0.7 there, 0.6 there, and a 0 there. So fingers crossed, let's see which one of these fits that. 0, 1.8, no, it can't be that one. 0, 1.8, 1.2, 0, 1.8, 1.2, it's definitely not that one. So I've got a choice between 2, 0.7, and 0.6. They have to be on the diagonal. It has to be B as the correct answer. Question 31. The Leslie matrix shows the results of a round-robin chess tournament between the players H, I, J, K, and L. In each game, there is a winner and a loser. 2 games are still need to be played. A 1 in the matrix shows the player named in that row defeated the player. At the end of the tournament, players will be ranked by calculating the sum of their 1-step and 2-step dominances. The player with the highest sum will be ranked first. The player with the second highest sum will be ranked second. Which one of the following is not a potential outcome after the final 2 games have been played? Which one of the following is not a potential outcome after the final 2 games have been played? Player I will be ranked 5th. First, player I, player J, player J. Okay. Seen this type of question before, so it seems to be a bit of an adaptation. And if we look at the way that we can actually fill these in, that can be a 1 or a 0. And a 1 and a 0. So, or we can swap those around and that can be a 1 and a 0. They can stay. Or we can swap them around and that can be a 1 and a 0. So there are 4 different ways of doing this. Okay. So ultimately, the only way I can think of doing this is by trial and error. So we're going to have, and I'm just going to do this quickly. I've got 1, 0, 1, 0. That's one of my options. I've got 0, 1, 0, 1. I've got my third option, which is going to be 1, 0, 0, and a 1. And my fourth option is going to be 0, 1, 1, and 0. I think those are my 4 options. So ultimately what I'm now going to do is fire up my calculator and see what actually happens here just by working this out. Once you've got the initial one in, it should be a case of sort of just adapting numbers. Oh, he just did cancel. My apologies. Trying to talk and do this at the same time is just crazy. And again, if you've got a better way of doing this, please, please, please reach out and let me know. So what have I got? 0, 1, 0, 1, 0, 0, 0. Right, let's go with my first one there, which is going to be a 1, 1, 1, 1, 0, 0, 1, 0. 0, 0, 0, 0, 1, 1, 0, 1, 0, 0. Okay, so let's put that into, let's call it D. Okay, well that was very silly. Let's try that one again. Let's go Control Store in D. I'm going to do D plus D squared, which gives me that. So if I now add all of those together for that, so for option number 1, I'm going to end up with 1, 2. So I'm adding all those scores together. I've got 2, 4, 6. So we've got H, I, J, K, and L. We've got 6, 2, 4, 6, 8. We got 2, 4, 5. We got 1, 2, 3. We've got 2, 4, 6. Right. So that's the sort of total of their dominant scores, as it were. Right. Now I'm going to go back up and change my value of D, and I'm going to choose, so he says that's going to be 0 and that's going to be a 1 there, and I'm now going to change that to a 1 and that to a 0, so that can't be right. Try that one again. So that would have to be a 0, so 0, 1, and that's a 1 and a 0. So do D. Let's do D plus D squared in that situation. So option number 2, if we write this down here, gives 5, 2, 4, 5, 3, 4, 5, 6, 7, 8, and then 3 and 2, 4, 6, 7. Option 3, he says, if I go back and redefine my option D, is now going to have a 1 here and a 0 there. And then that one there is going to be a 0, and that's going to be a 1. So D plus D squared, if you would. So option number 3 gives me 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, and then 2, 4, 6, 7, 8, 9. And option number 4, this is time consuming, isn't it? Option number 4 is 2 zeros, so that becomes a 0, and that becomes a 1. That stays as a 1. So D plus D squared gives me a sum of 2, 3, 4, 1, 2, 3, 6, 7, 1, 2, 3, 4, and 3, 6, 7, 8, and 9. Having done that, what it's asking, player I will be ranked. Which one of the following is not a potential outcome after the final 2 games in play? Player I will be ranked first. Player I would be ranked first. Well, player I would be ranked first here, and we're looking for not, so that's not one of them. Player I will be ranked 5th. All right, player I would be ranked 5th. Well, in this situation, player I would definitely be ranked 5th, so that's we're looking for a not. Player J will be ranked first. So where's player J? H-I-J-K, there's J. So no, yes would be ranked first there. So that's a no. I'm beginning to panic now. Player J will be ranked 5th. So player J would be ranked 5th. Nope. Nope. Yes. Player 5 would be ranked 5th. Oh, try again. Player what? Player J. Well, it helps if you look at the right one. So player J would be first there. I think that's a 3. No, I think that's a 5. So we'll go back to, I'm just going to check on that one there. So that's that one there. So I just want to check, what is that? H-I-J 2, 3, 4, 5. That's definitely a 5. Let's make that a 5 so we can make that there. So no, they're not last there. They're definitely not last there. They're not last there, and they're not last there. So thankfully, D is my correct answer. And again, that took some serious time to do. All right, there's more. Question 32. A large sporting event is held over a period of 4 consecutive Thursdays, Thursday, Friday, Saturday, and Sunday. People can watch the event at 4 different sites throughout the city: Botanical City, Riverbank, and Main Beach. All right, let SN be the state matrix, shows the number of people at each location n days after Thursday. Now, if you haven't subscribed to my YouTube channel and can, that would be great. And if you can like the video, then VCAR will, YouTube might turn and say, this is worth watching. That would be awesome. So few people watch this stuff. It's crazy. And yeah, everyone says to me, oh, you know what, Darren, your videos are awesome. If you spread it out there and tell your teachers, I would be blown away. Turn around and say to your teachers, you know what, this guy's content is pretty bloody good. Let SN be the state matrix that shows the number of people at each location n days after Thursday. The expected number of people at each location can be determined by the matrix recurrence rule that. Okay. Given the state matrix S of 3 that, the number of people watching the event at the Botanical Gardens from Thursday to Sunday has decreased by. Okay. Number of people from Thursday to Sunday. So what? Let SN be the state matrix after n days after Thursday. So this is Thursday. All right, so this is effectively my S0, Thursday. S1 would be Friday. S2 would be Saturday. And S3 would be Sunday. Okay. The number of people watching the event at the Botanical Gardens from Thursday to Sunday has. The number of people watching the event at the Botanic Gardens, G, from Thursday to Sunday has. Decreased by 162, decreased by, I don't understand what this question is asking. Because that's A. So now we need to be careful here because that's A. All right, so in which case S0 is on Thursday. Right, so we need to go back and basically find S0. Now, to be fair, the only way I know how to do this is to rearrange and say, well, S of n plus 1 minus A is equal to the power of t to the S of n. So t to the minus 1 of S of n plus 1 minus A is equal to the one before. So what we're saying is to get to the one before, yeah, I take the current one, subtract A, and pre-multiply it by the inverse of t. Now, normally speaking, there are better ways of doing this, but I can't think what it is off the top of my head at the moment. So I'm going to do this in the way that I would normally do it, and then maybe if I think of a different way of doing it, I'll let you know. So let's turn this on at the moment. So I'm going to put all this information in first. So I'm going to go, here we go. There we do that. We got 4 by 4. We have 0.4, 0.2, 0.4, 0. 0.4, 0.1, 0.3, 0.3, 0.1, 0.4, 0.1, 0.2, 0.1, 0.3, 0.2, and 0.5. I'm going to store that as T for my transition matrix. I'm now going to do A, and I'm going to put in there a, what do I want? 1, 2, 4 by 1. And that's going to be 300, 200, 100, and 300. Let's actually store that somewhere. Store that as A. And then I'm going to put S3 in. So how am I going to do this? Yeah, I'm just going to put, S3. Right, so put, again, 4 of these values in. 4 by 1 gives me 5620, 6386, 4892 and 6902, and let's store that as S3. As S3. Okay. So what we now know, using my formula, and I will highlight it here, is to get to my previous one, I'm going to do, so t to the power of minus 1. I'm going to multiply that by a set of brackets of s. So in this situation, And just bear with me. I'm going to delete this because I want S3 to be in my register, and I'll explain why in a moment. So I'm going to do t to the power of minus 1. I'm going to multiply that open brackets by my current answer, which is the one I'm currently dealing with, yeah, minus the value of a. So if I hit enter now, that is going to be my value of S2, S1, S0. So that's my value of S0. So my value of S0 is, he says, once again, drawing the wrong thing, 4924, 4732, 6540, I'm going to say, and that's going to be 4904. 4904. Now, it wants to be able to do, what is it, GE? The number of people watching the event at Botanicals from Thursday to Sunday has. So there is my S0. There is my S3. So I'm now going to do 5, 6, 2, 0. I'm going to subtract from that 49, what is that, 24, and give me 696. So it's increased by 696. I'm going to go, oh, with D as my correct answer. Again, there may be other ways of doing that, but at this moment, I'm not overly sure. And there we go. That's networks done. That's matrices done. We're now on networks and decision mathematics. If you haven't subscribed to my YouTube channel, if you could like the video, would be awesome. And he says going particularly dark. For those of you who may be preparing outside of 2024, then basically there is this revision booklet on Maths Guru that has all of the notes that I provide my own students, and VCAR questions in there and all sorts of stuff as well that you can absolutely have with a very small cost. And I'm sorry about that. It just covers my time. I hate charging for this stuff. But if you want to use it and you're supporting me, that's great. Right, let's go. Question 33. Consider the following graph. The sum of the degrees of the vertices is. All right, so this is going to turn around and say, well, that one has 1, 1, 2, 3. That has 2. That has 2. And that has 1, 2, 3, 4. Right, so there is an interest, and that's actually got 0. Right, that's got no degree whatsoever. A lot of people get tricked by this one here because it's at one edge, but it's actually 4 degrees. So it'd be 4, 5, 6, 7, 4, 5, 6, 7, 8, 9, 10, 11, and I'm going to go 12 as the correct answer. Consider the following network. An Eulerian trail through this graph could be. Now, again, be honest with you guys, I never remember what an Eulerian trail is. All right, sheesh. So what I'm going to do is flick through the summary book I just talked about a moment ago and go to my network section and find the page that basically lists all of the stuff about paths, cycles, circuits, trails. An Eulerian trail follows every edge of the graph. I know that much. An Eulerian trail will exist if it's connected, has exactly 2 vertices that have an odd degree. Okay, so I'm now going to say that's 2, that's 3, 1, 2, 3, 4, 1, 2, 3, that's 2, and 1, 2, 3, 4. So 2 vertices of odd degree is going to be F and B. So I can start at F and I'm going to end up at B. So first thing is I've got to start with F and end at B. So it can't be A and it can't be B because that's starting at F and ending at A. So that's no good to me. So let me see. And an Eulerian trail follows every edge. So let's just run it through. This will be cool. And I'm going to highlight as well in a slightly different color. So B to A to C, or B to A to C to B to D, B, A, C, B, A, C, B, D to C to F to D to E to F. Okay, so I'm going to say C is the correct answer. But never, ever would I just go with that. I'm just going to get rid of these and just check the other one because you never know, I might have made a stupid mistake. So B to D to C to A to B to C to D. Now I'm repeating. You can't repeat an edge, so it can't be D either. There we go. Good question. I really like that one. Consider the following graph. The number of faces is. Oh, guys, they do this deliberately to you to try and trick you. You have to redraw the diagram to be able to end up with the number of faces. All right, you cannot have lines crossing for it to actually be. So this line this one here, all right, would have to move to outside of here. And then this point here, you can drag to over there. So I'm going to try and redraw this. 1, 2, 3, 4, 5, 6, 7. Let me just check. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6, 7 dots. So that one connects to there. That one connects to there. I'm going to drag this one outside there. So what I've done here is that there, I've dragged outside. These two I've drawn here and here. This dot connects to there. So I'm going to draw that dot's connected. This one's connected up here. This one's connected all the way up there. This dot here is connected to that dot there. Now what I'm going to do is actually going to move that dot up here for a moment and see where we go with that. That connects to that dot. This connects to that dot. And this connects to that dot there. So if I move that one out there, and that connects to that dot there. So I'm just going to check the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 edges. Do I have 11 edges? Change color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 edges. I do. So now my face is, he says, doing it in green, is 1, 2, 3, 4, 5, and one outside, which is 6. So I'm going to go with B as my correct answer. All right. So again, I'm just going to drag that outside, which is going to give me 1, 2, 3, 4, 1, 2, 3, 4, 5. Now I'm tricking myself. Let's just check that one again. If only I could draw this thing in real world. So it's going to be outside. There's going to be one face there, one face there, one face there, and one face there. That will already have been counted, and one there. 1, 2, 3, 4, 5. Yep, 6 is definitely the right answer. Okay, woof. Next. Houses in an estate are to be connected to the internet via underground cables. The network below shows the possible connections between the houses. The vertices represent the houses. The number on the edges represent the length of cable connecting pairs of houses in meter. Okay. The graph that represents the minimum length of cable needed to connect all the houses is, okay. Minimum spanning tree, love, love, love. The best thing to do here is I'm going to use Kruskal's algorithm. He says bringing out that. And if you don't know what Kruskal's algorithm is, you probably haven't done year 11 year 11 general maths, or you haven't watched mathsguru.com. It is there for the taking. But let's see where we go with this one, because what have we got? The number on the edge represents the length of cable connecting pet. Yep. So the minimum spanning tree always start with the smallest value. Kruskal starts with the smallest value. So what is that? 14? I reckon it's 14. Yep. Then we're going to go 15, and then 16. 16 here. Is there any other 16s? Nope. Then I've got a 17. I've got an 18 here, but I can't connect it because it would create a loop or a circuit, so I can't do that one. Okay, so what have we got now? We've got a 18 here I can use. I've got a 19. I can't do this because, again, it would create a circuit around here or a loop or whatever you want to call it, he says. And so what do I have? A 19 there, but I can do a 19 here. A 20. And basically 20, 20, 20. No, I think that's it. So I just want to check because I want to create, I've got 1, 2, 3, 4, 5, 6, 7, 8 vertices. So I must have 7 connections. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Yep. So there we go. So let's just see if we can find the one that looks like that diagram there. Bum bum, bum bum, bum bum. So again, I think D is my correct answer there. Just want to make sure that that's, yep. 1, 2, 3, 4, 5, 6, 7. No. So I'm going to say D is my correct answer. Kruskal is great. If you use prims, you should have theoretically got the same answer. But basically, yeah, the network below represents paths through a park from the car park to a lookout. The vertices represent various attractions, and the numbers on the edges represent the distances between the meters. The shortest path from the car park to the lookout is 34 meters. This can be achieved when? All right, so if it's the shortest path, It's basically going to be Dijkstra's. And we want to go from the car park to the end, to the lookout. All right, so the shortest path from the car park to the lookout is 34 meters. Now, you could probably do this by trial and error 5 times. I'm going to try it with the algebra way, and let's just see what happens. So I'm going to put a 10 on there, and I'm going to put an X on there. Which is the smallest value? That's a very good question. Because to be able to do Dijkstra's, and again, I'm thinking out loud now. You're probably sitting there going, no, you have to do it by trial and error. Okay. The shortest path is going to include X and Y. So in which case, X plus 7 is going to be shorter than... So I'm going to put X as the box. I'm going to put a box around X, he says again. Put a box around X because that's going to be the one I choose. Yeah, this is gonna fox me a little bit, so bear with me. X plus 7. Now, let's try it the actual way. All right, let's make X equals 8. And let's make Y equals 8. And let's see if we can do Dijkstra's really quickly. All right, so there's 10. That's going to be an 8 there. I'm going to choose the 8. 8 plus 7 gives me 15. All right, so I'm going to choose, sorry, that's 15. 8 plus 12 gives me 20. Have I got all my connections from there? Yep. And so what have I got? Smallest number is 10. All right, 10 plus 7, nope. 10 plus 11 gives me 21. That's all my connections from there. Which is my next smallest number is going to be 15. 15 plus 5 gives me 20, so that now becomes 20. 15 plus 13 gives me 28. 15 plus 5 gives me 20. I'm already at 20, so I've got a 20 here. 20 plus 8 gives me 28. 20 plus 8 there gives me 28. So I've got a 20. 20 plus 8 gives me 28. I've already got 28 there. 20 plus 7 gives me 27. Okay, so what have I got here? 27 is my smallest value. 27 plus 9 gives me, that's a very good set, 36. Okay, so what have we got here? 28 plus 36. So my next number is 28. 28 plus 8 gives me 28, 29, 30, 36. Okay, and then 28 plus 7, 28, 29, 30, 31, 32, 33, 34, 35. So it's not A. Okay, rub all this out and try again. Someone actually messaged me on Facebook, on YouTube, and said, would it be better just to start from the bottom? My teacher says to start from the bottom because ideally with these longer questions, VCEE are here to trick you. Very good question. The lighter questions in these exercises are there to try and slow you down and spend a little bit longer. So we'll see where that sort of falls with you. X equals 9 and Y equals 7. It's made more interesting because, yeah, anyway. So that's going to be 9, put a box around it, and that's going to be 10. So 9 plus 7 gives me 16, and that's 9 plus 12 gives me 21. All right, smallest number is 10 again. 10 plus 7 is 17. 10 plus 11 is 21. So my smallest number now is 16. 16 plus 5 is 21. 16 plus that is 29. 16 plus 5 gives me 21. All right, so we're at 21. Let's do 21 plus 8 gives me 29. 21 plus 8 gives me 29. We're already at 29. And so we got that. All right, what are we? 21. 21 plus 8 gives me 29. 21 plus 7 gives me 28. My next smallest number is 28. 28 plus 9 gives me 37. Whereas my next smallest number, 29. 29 plus 7 gives me 36. 29 plus 7 gives me 36. So no, it's not B. Start again. Obviously, I suppose the thing here is speed. If you can do this relatively quickly, 10 and 6 I'm going to be devastated if it's D is my correct answer, but we'll give it a go. So there's 10 and there's 10. All right, so choose the 10 plus 1 gives me 21. 10 plus 7 gives me 17. Got another small number. 10 plus 7 is 17. 10 plus 12 gives me 22. Where do we go now? Have I got all my smallest numbers? Yep. So where's my next smallest number? 17. 17 plus 5 is not smaller than 21. 17 plus 13 gives me 30. 17 plus 5, 17, 18, 19, 20, 21, 22 gives me 22. 21 is my smallest. 21 plus 8 is 29. 21 plus 8 gives me 29. That becomes 29. Where's my next smallest number? 22 plus 7 gives me 29. 22 plus 8 gives me 30. So I'm at 29 with all of those. 29 plus 6 gives me 29, 35. 29 plus 7, 29, 36. And 29 plus 9 gives me 38. So no to C. Here we go. I'm going to get really, I'm going to cry because of the length of time this has taken. There's got to be a quicker way to do this. So if you do know the quicker way, let me know and explain it slowly. 11 and y is equal to 5. Here we go. Right. That's going to be 10. All right, and that's going to be 11. 10 is my smallest number, so we go back to 21, which is feeling terribly repetitive. And then 10 to there is 17. All right, that smallest number now is 11. 11 plus 7 is 18, so that's now got 11 plus that is 23. Smallest number is going to be 17. 17 plus 5 is not smaller than that. 17 plus that is 30, he says, writing in rubber. 17 plus 5 is 17, 18, 19, 20, 21, 22. So that becomes 22. 21 is my smallest number, makes that 29. 29. 21 plus 8 makes that 29 as well. Yep, 21. 22 is my smallest number. 22 plus 7 is 29. 29 is my next one. 29 plus 5 gives me 34. There we go. D is my correct answer. And now I want to cry, but there we go. That was a way to do it. Okay, now moving on to question number 38. A connected graph has 6 vertices and 6 edges. How many of the following 4 statements must always be true? Ooh. So I've got 6 edges, 6 vertices. 1, 2, 3, 4, 5, 6, and 6 edges. So let's connect 1, 2, 3, 4, 5. Let's do that for the moment. The graph has no vertices of odd degree. Well, in that situation, they are 2, 2, 2, 2, 2, 2. All right, so that's, but if, for example, I move that one there, it's still got 6 edges, it's still got 6 vertices, but now that has an odd degree. So it's not always true. It can't be that one. All right. The graph contains an Eulerian trail. Now, checking my summary book, an Eulerian trail follows every edge of a graph. An Eulerian trail will exist if the graph is connected, okay? Has exactly 2 vertices that have an odd degree. That's 1, 2, 2, 1, 2, 3, 2, and 2, right? So in that situation, it's got 2. Can I draw it in another way? Can I draw it in another way so it's still got... So if I draw it that way, and that's 2, and that's 2, the graph contains an Eulerian trail. An Eulerian trail follows every edge. An Eulerian trail will exist, but an Eulerian circuit is an Eulerian trail, and an Eulerian circuit has even degrees. So that is possible. That is possible. So in which case, it doesn't matter where I move these 2. That is going to have 1, 2, 3, 2, 2, 2. So let's say that's always right. A Hamiltonian path. A Hamiltonian path visits every vertex of a graph. Would visit every vertex of a graph. The sum of the degrees of vertex is 12. 2, 4, 6. 2, 4, 6, 8, 10, 12. That one is definitely 12. But if I connect... Oh, dear. Let's just go back. If I connect that like that, 1, 2, 3, 4, 5, 6, That becomes 1. That becomes 3. If you add those together, you get 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How would I draw this in a different way without it? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's another way of drawing it I hadn't thought about. So that's 1, 1, 1. 1, 2, 3, 4, 5. 2 and 2. 5, 6, 7, 8, 9, 10, 11, 12. That's always 12, but let's go back. So that's 12. That's 12, and the other one was 12. So I'm now going to rethink that one. Let's put that back on. It has an Eulerian trail. An Eulerian trail has 2 odd. Has exactly 2 vertices that have an odd degree. Well, in which case, no, because I can now draw 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And in fact, that does not have an Eulerian trail and has a Hamiltonian path, visits every vertex. 1, 2. Graph consists of a Hamiltonian path. Bum, 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 bum. Can a Hamiltonian path repeat things? Can a Hamiltonian path repeat things? That's a very, very good question. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Try to work out if you can actually draw this in a different way. This is one of those questions now that I'm a bit... the graph contains a Hamiltonian path. Okay. So I've just pulled up the textbook and it says a Hamiltonian path and cycle do not repeat vertices. And in this situation, I cannot get to a situation where I don't repeat vertices. And so always a good idea to check the summary book. So I'm going to cross that one off. And in which case, I'm going to say A is my correct answer. Okay. Whew, that was tricky. Now, moving on to question 39, and I have to say, I paused video for this one because it was fascinating trying to get my head around the actual, what it was asking. But Anoush, Blake, Carly, and Dexter are working on a construction site. They're allowed one task of the time and hours it takes for each worker to complete each task is shown in the table below. So there we go. The minute I saw this was like, yay, it's a Hungarian algorithm question. But I think VCAR now got smart because now that there is this CAS program that sort of takes away a lot of the grunt work, they have to come up with more interesting questions. The task must be completed sequentially in numerical order 1, 2, 3, and 4. Okay. Management makes the initial allocation of tasks to minimize the amount of time required, but then decides that it takes the workers too long. Another worker, Edgar, is brought in to complete one of the tasks. His completion times in hours are shown below. When a new allocation is made and Edgar takes over one of the tasks, the minimum total completion time compared to the initial allocation will be reduced by it. Now, I have to say, maybe the wording is interesting here because I read it lots of different ways. But what I think it's trying to suggest is Edgar actually replaces one of the people. Because it could be taken that Edgar basically replaces Anoush's 9 or Blake becomes 9 and Carly, I think that's one way of doing it. That's not the way I have done it. And fingers crossed, at least one of the answers I've got is this. So the first thing I did is I'm going to turn on my calculator. And if you have the Hungarian algorithm, it's going to make life a lot easier. At least it certainly did for me because I wasn't doing all this. And there may be other ways of working this out. I don't know. Maybe I'm a little over-reliant on the calculator at the moment. Now, first thing I did was it said that the management decided to make an initial allocation. So we needed to work out what the initial allocation was. And there we go. There is my initial allocation. So I put in my value of C of 12, 8, 16, 9. So basically just put that table in. Went into screen 2, menu, matrix, user defined, C, and hit enter. And what it came out with was that under the initial allocation, we got 43, what would that be? Minutes, hours, whatever else. I don't remember what the units are. So 43. If you then take it that Edgar is going to replace, say, Anoush, you need to go back. And now what I did was where Anoush originally was, I have replaced it with Edgar. So I've basically taken out Anoush's time and I put in Edgar's 9, 5, 14, 8. So what I'm going to do is copy this down. Nope, let's not do that. Let's try and copy down the whole thing. Where are you? So it's that one. Hit enter. I went back into my display. I went menu, user defined. You have to, for some reason, keep doing this. I don't know why. But then it told me that if that was the case, the total time would be 42. Now, without making this video too long, I then repeated it and replaced Blake with Edgar, Carly with Edgar, and Dexter with Edgar. And when I did that, when Blake was replaced, it became a total time of 41. When Carly was replaced, it became 39. And when Dexter was replaced, it became 40. And so in which case, the biggest difference would be to go from 49 to 43 to 39, which would therefore save me those many hours. God, fingers crossed that is going to be the correct answer. And now moving on to the last question, question number 40. Oh, I'm exhausted. A project has 15 activities A to O that need to be completed. A directed network that represents this project is shown below. The activities are not labeled. Ooh. The activity table that could represent this project is... Okay. Now, I've just worked through this off camera, and to be honest with you, the only way you can do this is by trial and error. There is no way to be able to do this. You've just got to know what you are doing relatively quickly. So, if you have the paper in front of you, which I think you probably do, because I think you're allowed to take this one out with you, this is how I did it. And I'm going to zoom in nice and large because there's going to be a lot of sort of trial and error. So the first thing I did was start with A, and I said, right, A, B, C, D, come off the start. That's what those little dashes mean. So if I now make this A, B, C, and D, just arbitrarily for this moment, they could obviously move around, but we'll see. E has to follow A, okay. F has to follow B. G has 4 predecessors. So G has to have 4 things coming into it. So that could be G coming into there. I mean, as 1, 2, 3, 4. 1, 2, 3, 4. That could also be G because they're the one that got 4 coming into it. But G has got E, F, C, and H coming into it. So that now means that this one's got to be G because actually E, F, C, and H. No, that can't work. Automatically, I don't think that can work. E, because E has to follow A. All right, hold on a moment. E has to, what did I say it was? A, B, C, and D, right. F has to follow B. E, F, C, and H. Well, F is coming in, C is coming in. That either that would have to be H or that would have to be H. But E basically can't go into G. Can I move things around so that G can be followed by E, F, C, and H? C, H, F. Well, the only way that's going to happen is if that's E, and then there is nothing in there. So basically, A just cannot work. So I discounted A from there and said, nah, there is no way to be able to do that. So obviously, then I moved on to B. Now, it's really easy to discount B because we don't have the dashes by A, B, C, and D. And I think that was meant to be the trick for this question because we get so used to it being there and sort of the dashes are already, you know, A, B, C, and D, then we sort of could automatically discount it. But let's assume we don't. Let's have C, D, H, and I. And again, I'm arbitrarily doing it. Now, as I was working through this, I basically put ticks off, tick, 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 and tick, just to see that I didn't duplicate something. Now, then I just worked down, okay? A has to follow C. All right, so let's make A follow C. B follows A. All right, so that can either be B or that can either be B. All right, and the great thing about doing this in pencil means you can rub it out. E must follow A, right? Okay, so that can be E or that can be E. Now, F has to have 4 predecessors. So again, F has to have 4 predecessors. This is the only dot on there that I believe, 1, 2, 3, 4, or this one here could be F. All right, so that could be F or this could be F. But F has to be has predecessors B, K, M, and L. So B, K, M, and L. Well, in which case it can't be this one here because that's got B or E and H and whatever. So that can't be F if this one is correct. So this would have to be F. In which case we now know that that's got to be B because B's leading into it. and that therefore would have to be E there. So let's just draw that again and make that E. Okay, and again, this is just me working around. G follows D. Is that possible? Well, I can make that G following D. H and I have already ticked. I follows J. Oh, sorry, J follows I. So that can be J, or that could be J, or that could be J. K is E, G, H, or J. So K has to be, again, 4 immediate predecessors, or 4, yeah. So that's got to be K if that's true. So I've got E, yep. I've got G coming in there, yep. I've got H coming in there. So that has to be J, all right? This is like a puzzle, really, isn't it? So if that's true, L follows N. Well, hold on a moment. I don't have an N anywhere in here, so I'll skip that one for the moment. M follows I. So that has to be M, or that has to be M. N follows I, so that's got to be an N or an N. And O follows N. Well, in which case, this cannot be N because F is following it. So that has to be M. That has to be N. O follows N, which means O is there or there. And then we go back to one that we missed earlier, that L follows N as well. So that's got to be an L, or that's got to be an L. And the decider here is to go back to F, and F is predefined by P, B, K, M, or L. So F, that would have to be L. And in which case that would be O. So looking at B, that is the one, or one that definitely works. And to be honest with you guys, I'd stop there, because yes, if I had the time, I probably would go through the others. It's, you know, because I went through that relatively slowly, I'm fairly sure I didn't make a mistake, but I'm going to go in that situation with B as my correct answer. Now, if you can subscribe to my YouTube channel, that would be awesome. If you can like this video, that would be even better. I would be blown away if that's possible. Remember, if you are just revising or about to start, there is this revision resource on Maffs Guru that you can sort of download. There is a small fee. It's just to cover my cost, and I'd be deeply grateful, obviously, if you're there. Sign up to maffsguru.com because there's so many videos on there to help you as well. But I think I'm done. That is the end, I believe, of this paper. And so I am going to bid you adieu. Good luck for Monday if you're in 2024 and that's coming up. And I hopefully will do the solutions for that as well too. But take care and please stay safe.